Hi, today I'd like to cover some applications of valuation, and here it'll be more about projects. So what I'm going to try to do is I'll set it up as choosing among alternatives. And one of the things that we want to kind of always keep in mind, that we always have choices. And as I've always maintained about finance, is that it allows you to think clearly about decision making. And so a lot of the flavor of the applications we'll do will have that sense of choice in them, even though it's not that obvious. I'll do classic applications. By that I mean it's consistent with my teaching style or my way of communicating. I believe in building blocks. I believe in Lego. If you play Lego, you need to understand the pieces before you can make a design. And the beauty about finance is the pieces are really, really good. And once you get a sense of them, you'll be able to apply them. And the pieces could be big or small. So today we'll do applications that are a little bit bigger pieces, but based on a design or a set of principles you already know. So let's get started. The first principle we'll talk about, or the application we'll talk about, is a very famous application, been there in economics for a long time. It's called optimal timing of a project. So let me just ask you the following. Suppose you're considering a project and it does not look like a positive value creation project, or as we say in finance, positive NPV project. So the question there follows is do you have choices? And so the seeming obvious answer would be, so you're considering one project, what choice could you have if it's not a positive NPV project except say no? Well, not quite. If you think a little bit more about it, what you realize is that finance, because it's the study about decision making, and because decision making can happen today or in the future, you always have a choice. So if the project looks negative value today, heck, it could be positive value in the future. This basic notion is also introducing you to what's called option theory, is that you're not forced to make decisions. You always can walk away or postpone. Similarly, typically, if you see a positive one project and it looks positive NPV, remember the last scenario was that it wasn't positive NPV. But suppose now you find it to be positive NPV. Does that mean you should do the project? Typical answer again would be, of course, it's positive NPV, you should do the project. But when you think about it a little bit more, you'll realize just because it's positive NPV today doesn't mean that you do it today. It could be the case that postponing a project may make sense. So I hope you're getting a sense here that you always have choices, even if there's one project. And this is a wonderful application, and you will see it everywhere. For example, let's take the case that you decide to do an MBA. The choice is not just between alternative MBA programs, or choices doesn't have to be about the best one you chose among them today. You can always postpone the decision. Now, obviously, these applications are not in every case relevant, but they're highly flexible situations for you, which makes you think in a creative way. And here, I'll just look at one project. So the choice set you have is a project competes with itself over time. Basically the notion that even if you have one good idea or a bad idea, you always can implement it in the future. So suppose you have a great idea for a new technology that will replace fossil fuel-based energy. Now I want to make it exciting so that you get involved and you want to listen to what I'm talking about. So suppose it's that, and what you're trying to figure out is, heck, when should I do this project? So that's the question again. At what point in time should you introduce the technology? And the goal always will be to maximize the value of your company, or the value of your decision, therefore the value of your company. So remember, value creation is at the bottom, is in the background all the time. And it's simple. Its benefits should outweigh costs of making the decision. Now, in order to answer the question as to when should you do the project, you need to have done some analysis. And I'm going to presume you've done it already, because I'm going to go every time back and start doing basic valuation. So let me just put up some numbers for you. So suppose the discount rate has already been determined as 12%. And I'm sorry, I'm going to ask you, where does that come from? And you know there are two decisions you always have to think about while making decisions. And one is, what is the cash flow? The other is, what is the discount rate? So in this case, the discount rate is 12%. You've done your analysis, and the discount rate doesn't belong to you or the project. It belongs to the next best alternative, which in a marketplace can be measured. You've also conducted some analysis. And here, if you look at the table right in front of you, if you did the project today in $1 million, you'll make $75 million. Next year, if you introduced it, you'd make 96.67, and so on. So there are some numbers given to you. These are not cash flows in the traditional sense, like we normally used to thinking, right? Normally you think of one project that gives you cash flows in the future. The way I would want you to think about this is the following. If you were to execute the project today, you would create $75 million worth of value. It's positive. That's why it's interesting. However, you've done your market analysis and you say, if you were to start the project 1 year from now, the entire project, your market value or NPV at that point would be 96.66. Then it will be in year 2, 116.25. You get the drift. So all you're doing is you're moving across over time. Like I say very often, you need to watch Matrix, because if you know how to time travel, finance becomes pretty easy. So you're imagining yourself at future points in time. Of course, this NPV analysis is tough to do, but people do this all the time and should think about the future in a very dynamic way. So I've done that work for you, and each is an NPV decision with one important difference. You can call it a cash flow. So if you could kind of sell your firm in time one, create and sell it, you should get 96.66 million. If you create your firm and sell it right away today, if you could possibly do that, you'd get 75 million. So in some senses, these are cash flows. The difference, of course, is what? Time, as always. So if you were to create the firm today, 75 million, 1 year from now, 96.66, and so on. So the question really is, think about it some. And by the way, I will ask you to think. So pause whenever I say that, because I can't just keep pausing and making the movie. I like the flow of it. So what I would recommend to you is just think about it. Can you make a decision here? And the answer is, when you look at these numbers, you should immediately figure out something, is that you can't directly compare these numbers, just like you can't compare money over time. And as I say often, if you start comparing money over time without discounting, you might as well stab me, right? Because that's the 101 of finance, is you don't compare things over time. You bring them back to time zero or some particular point in time. So I've given you the discount rate. So let me do something now for you. Same question. When do you start the project? But if you look at the table and if you stare at the numbers, you have two rows. One of the rows, and let me clarify what I'm saying, and I will not write unless I have to write, is that the first row, of course, shows you the year in which something is introduced. The second row is called NPV sub T in millions, is 75, 96.66, 116.25, exactly the same as in the last time I showed you this table. But if you look one step below, what have I done? I have done something very simple, which you should know by now, is I've simply taken the present value of all future values to today. So if you look, you'll see NPV 0T. So just so that I start kind of annotating a little bit, if you see a 0 over here. Now that 0 signifies what today? Notice there's no 0 on the top part. Why? Because these are occurring at particular points in time. So one way to think about it is, I couldn't compare the numbers in the top row, but now I can because I've adjusted them for time. How would you do that? Now this is very simple, so I'm not going to answer the question for you, except tell you how it was done. The first number, 96.66, will be needed to go back to time 0. And that's the number it turns out to be. Why? First, when you discount at a positive rate, the number has to come down. The second, how did I go from 96.66 to 86.3? Well, very simple. 96.66 divided by 1 plus 0.12 is discounting for just 1 year. And the number you get is 86.30. I would encourage you, even though it's very mechanical, to do this exercise all over again. So now the neat thing about all of this is we can compare the second row or the last row here with each other because we have discounted, we have taken away the effects of time. Now you stare at this and you should be able to tell me which year do you introduce the project. And the year happens to be what? The one with the highest NPV. So think about it like this. You had one project when you started, and I made it into 6 projects by simply spreading out the decision over 6 periods, points in time, not periods. 5 periods, 6 points in time. And you'll pick which one? Year 3. And why? Simple. The value of that decision today is $95.45 million, which is highest among all the possible values in the last row. It means introduce in year 3. I hope this is clear. I'm not going to do the calculations behind all of this. I just wanted to show you how a project competes with itself. And when you use NPV analysis, you can pretty much pick the highest NPV. But here you have to think about it a little bit. So, another interpretation. I'll throw in a center row and I'll ask you to pause and think about what the center row is. So if you were to just stare at those numbers, the first question is, it shows percentage change in NPV. I'm talking about the middle row. Remember, I'm talking about this row. So the question here I'm asking you is, what does this row signify and why did I do this row? This is a very interesting point. So start with this number. How did I get it? Well, it says how much did NPV change between period 0 and period 1. So going from here to here, what was the percentage change? Do it yourself. It's very simple. I'm going to talk and you do the writing. It's 96.66 minus 75 divided by 75, and it's a percentage. Similarly, how did I get this number? Well, it's a change between this period and this period exhibited in percentage change. So now, what is the difference between the row with the dollars and the row with the percentage? The difference is something we have seen over and over again. Dollar signs tell you value at a point in time. Of course, the difference between the NPV-T and NPV sub naught T, these two rows, this and this, is just that one is in the period in which is happening and this is all at time 0. Therefore useful for decision making. But if you look at the percentage change in NPV, that one is a little bit strange. It looks more like a rate of return, doesn't it? So because it's a rate of return, try to think about what would you compare it to. Again, pause. Take a pause. Pause my video. And before you answer the question, try to think about what significance does it have. And you'll suddenly realize that the percentage number that you are given in most finance problems is R. And it is 12%. Now stare at that 12%. What does that tell you? There is some break point where 12 falls in that entire row. And if I may just point you to it, it falls exactly here, somewhere between the 15.4 and 11.9. So what is this saying to you? This is saying that you could mimic the NPV positive decision-making rule with what you normally think of is kind of a rate of return or IRR rule. But here the IRR rule is a little bit complicated. It's not the traditional IRR. It's the IRR or the value of postponing by 1 year. So if I postpone from year 0 to year 1, the return percentage change is 28.8. Think about it. Is the value of your NPV decision growing over time? The value of postponing by 1 year? Yes, 28.8. But is that more than the 12%? Answer is yes. So you'll keep postponing till postponing is a value creating step, right? Look, there's value creation everywhere. So when you're thinking of postponing by 1 year, you compare 28.8 with 12% and you say, well, of course I won't do the project today. Then you go to 20.3. Will you postpone again? Sure, because you still are creating more value by not executing today and so on. This is, by the way, also called a tree cutting problem, and I'd like to talk about it right now. By that I mean the following. In forestry, as in nature, we sometimes do cut down trees, right, to make something else. But the beauty about trees is they grow, right? So they grow and they become more valuable perhaps. So there is both real growth of the tree and price growth of the tree over time. So you may not want to cut the tree right away. You want it to be cut optimally. So here what's another way to think about it is the tree's value is growing at a rate faster than 12% till which point? Till end of year 3. And therefore, would you like the tree to grow or cut it? Remember, 12% is reflecting the next best alternative. What would you do if you cut the tree? Well, if you cut the tree too early, you're not letting it grow optimally. You're cutting it too fast. Similarly, would you introduce this project in any time before year 3? Answer is no. Of course, the important step here is that I'm artificially dividing time into 1, 2, 3, 4. The decision you will make is somewhere along a time spectrum. In this case, we are saying that after point 3, the rate of growth is 11.9 and before it, it's 15.4. I hope this makes sense. Okay? One graphical representation, and I find this really, really interesting. So let's put time 0 here, right? So on this axis, we have time, which is the x-axis. On the y-axis, we have NPV. So think about the slope of this line. Well, it is 1 plus r. The slope of this line is reflecting the growth given by the discount rate, right? So the slope is positive. So what's true of all points below this? If you notice, the rate of growth of the NPV is greater. G, growth rate in NPV, is greater than R, which in our case was 12%. But after this point, which in our case was 3 years, there is no point postponing or letting the tree grow. Why? Because the NPV now has a lesser slope than the next best alternative. So the same decision-making process works both ways, always. And what you're always trying to compare is when is it good to make a value-enhancing decision. And I love this graphical representation for 2 reasons. One, it's not step function, it's smooth. Second, many people like things to be visual. You may use the math, you may use the graphics, but the math and the graphics has to be consistent with each other. Here the graph is smooth simply for the ease of exposition. One little comment here. The graph is smooth and the NPV is steadily declining. Now this is where it becomes challenging, is because if I were to ask you, how would you choose between different projects, you would probably go back and say, well, I will choose based on IRR or NPV. I've given you both kind of ways of thinking about it. But there's a danger of using IRR kind of thinking. Here the NPV function is smooth. Suppose the NPV function was kind of erratic. It went up and down and so on. My sense is, and my suggestion is, always use value enhancing decisions based on NPV rather than IRR. And there's a very interesting class I teach on sustainability in finance, where I introduce a tree cutting problem which is very, very complicated. There's growth rate in prices, there's growth rate in the timber, and then I ask you to make a decision based on both sets of rules. And what you'll recognize is that NPV always gives you the right answer because it'll maximize value. IRR, or the rate of return based decision making, may actually give you the wrong answer and a myopic answer sometimes. What I'm going to do now is I'm going to take a break so that you can kind of think about this problem, go back, work through it, and try to recognize and think about what are the issues that you confront in real life and whether they are applicable to this scenario. I would encourage you to think about decision making. Like I gave you another example, is you could do MBA, yes. Value enhancing, yes. Even today, yes. But you could be better off doing it in the future based on what your future looks like, right? So turns out that you can apply that concept to many, many different areas. And smart firms and smart people think dynamically. Okay, so I'm going to take a pause now and see you in a little bit.